Today we're going to be talking about solving equations using algebra. In this video we're just going to be talking about one-step equations, and we'll do two-step equations in another video. A one-step equation is one that you can solve by reversing only one operation. So the equation has only a single operation acting on a variable: multiplication, division, subtraction, or addition. We'll talk about how we undo those operations in a minute. First, we're going to look back at this balance that we saw a few weeks ago. As you might remember, as long as I do the same thing to both sides of the balance, this will stay balanced. So if I want to, I can add candies to both sides, and this should stay balanced. When I'm solving an equation, what I want to do is I want to get the thing that I don't know. In this case, it's this egg that has some number of candies in it. I want to find out what this value is. In an equation, this will be represented by a letter. Sometimes this is called a variable or an unknown. How do I get my unknown all by itself? I've got the chocolate egg on one side, and I've got mints on both sides. If I want to know how many mints this chocolate egg is equal to, I have to get it by itself so that I don't have a mixture of mints and the egg on one side and just mints on the other side. I could represent this as 1 egg plus 5 mints equals 9 mints. That's how many candies I have in the plate. So 1 egg plus 5 mints equals 9 mints. How do I get the egg all by itself? Well, in this case, it's pretty easy. I just take candy out of this side. But I can't just take candy out of this side. For every candy I take out of this side, in this case it was 5, I have to take that same number out of the other side. So what did I do to each side here? I took away, which is another word for subtract, 5 mints. So I subtracted 5 mints from both sides. And this is exactly how we can solve an equation using algebra. Whatever we do to one side, we can do to the other side. We have to do it to the other side. We don't have a choice. We have to keep the equation in balance. We have to preserve equality. That means we have to keep what's on both sides of the equal sign equal to each other. And we can do anything we want to each side. I could add 1,000 mints to both sides. They would still be equal. Think about it, if I had two people over here that I was sharing the candies with, and they were concerned with fairness, they might be okay as long as I took 5 away from both of them. But if I took 5 away from one of them, watch out, because one of them is going to get upset. So solving an equation is all about doing the opposite operation that I have before me. In this case, I had 1 egg plus 5 mints, and so I took away 5 mints. So the opposite of addition is subtraction. The opposite of subtraction is addition. Now how do I get rid of multiplication? Well, what's the opposite of multiplying? It's dividing. So if I was to take these candies out, I'm going to divide each side by 3. So I'll make 3 piles on each side. In this case, this side, each of the piles only has 1 egg, which is going to make it really easy for me to see what 1 egg is worth. Okay, so I have 3 different piles. 1 egg equals 4 mints. So to get rid of multiplying, we have to divide by whatever number we multiplied by. Let's try the examples in the notes. One more thing, Mr. New has an acronym for this. It's called DOOBS. Do opposite operations on both sides. Unfortunately, my iPad screen recorder was not working, so I have to make do with this setup. Before I get started, I want to mention that I didn't make these. These were made by Miss Clemens Brenton. I think she's a teacher in Newfoundland. She's got a good website with lots of extra work. Also videos on YouTube to help explain too. And you should go check it out. So before I solve the examples, I want to just remind you of something I mentioned earlier. That was Mr. New's acronym. It was DOOBS with 3 O's. What does that stand for? It says do opposite operations on both sides. Very important to remember. It also says something similar up here. Remember to keep the equality. Whatever we do to one side, we must do to the other side. That is a key word right there. Must do to the other side. So let's look at this example. And now in these examples, it says solve the following problems using algebra and verify by substitution. I'll mention what verifying by substitution is after I find the solution to x. So personally, I like to rewrite the question, but that's not necessary. And I do want to make one point clear. What we're doing right now is building the foundation for learning or for solving more complicated equations later. So this question is extremely easy as it is right now. None of you need algebra to solve this. You could look at that and figure out what x is without doing anything. What we're practicing here is writing down our math work properly communicating what we solve in math so that anybody can understand it. And this may seem a little bit redundant and a little bit basic, but gotta start with the basics before you can master the advanced stuff. So I rewrote my equation, and now I have to do the opposite of what I have here, and I want to get x all by itself. The opposite of adding 4 is subtracting 4. So I'm going to do that to both sides. I like to make sure that my equal signs are lined up. And also a tip that I recommend to make sure that you're doing the same thing to both sides is you can use a different color or a highlighter to make sure that you see the same thing happening on both sides. So now I can clearly see that I've subtracted 4 from both sides of the equation. And then I simplify by doing the operations that I have. So the whole reason why I subtracted 4 was to get rid of this plus 4. So I'm left over with just x equals, and 7 minus 4 is 3. There we go. We could have seen that before without doing any algebra work. But like I said, we're learning how to write down our work properly, to communicate it properly using mathematical notation. Now I want to verify, and the way that I do this is I substitute this value of x that I found here. I'm going to put it back into the original equation and make sure that both of the sides are equal. One of the nice things about an algebra problem, and oftentimes when you're substituting a variable and you put it in brackets like this, the brackets don't mean anything. They just mean that that is replacing something else. And we want to check, does the left side equal the right side? And in this case, we can clearly see that it does. 7 equals 7, which means I got that one right. Great. So we should never get one wrong. If we verify our solution, we should always get the right answer. Next question, x minus 1 equals 5. Again, the opposite of subtracting is addition. So I'm going to rewrite my equation. Everything from the first line should be in this line. And what do I have to do to both sides? Well, I've got to do the opposite of subtracting 1, which is adding 1. And I do that to both sides. I make sure that it's both there on both sides. I can see it clearly in the pink color. And I simplify, x equals 6. Verify, I'm going to sub 6 back into the original equation. 6 minus 1, and that's clearly equals 5. There's not really a lot of steps I can show. 5 equals 5 if I want to. And sometimes you'll see LS equals RS, which means that the left side equals the right side. So I'm good to go. Next up is multiplication. Remember, the opposite of multiplication is division. And it becomes more and more common to see this written this way, like it's a fraction. And so I don't have to guess anything here. It tells me exactly what to do in the question. I see 3 times x, and I want to get rid of that 3. So I have to divide both sides by 3. The way that it's written here might look a little bit confusing right now, but this is getting comfortable with this kind of notation is really key when you're doing your math work. Simplifying fractions is going to make your life a lot easier. 3 over 3 is just like the same as 1, and 1 times x is the same as x. And then 24 divided by 3 is 8. And I can verify that by putting that back into my equation. Oops. Sorry for the mess. And I can see that that is 24. So I'm right. 20. My left side equals my right side. The last one is the trickiest one that people have. Sometimes people will look at this and they'll say, oh, x equals 1 because 7 divided by 7 is 1. That is way off of the actual answer. So I'm going to make something that looks like this down there. So you see this pattern with the 3 over the 3. I need to do that same thing with that 7. So again, there's no guesswork here. This is going to be really easy. Keep in mind, you want to have the same thing on both sides, and this is where people mess up sometimes. I've got x over 7. So what am I doing to both sides? I'm multiplying by 7. And when I have multiplying times a fraction and it's the same number over here as it is on the bottom, I could easily rewrite this as 7x over 7, just like I had up there with the 3x over 3. And so these two things, they cancel each other out. And that's really the key thing to remember there is that's a whole reason why I did this, is to get rid of that 7. So if I didn't do something to get rid of that 7, then there was no point in doing it. I wanted to use the least number of steps that I can. So, and then I just do the math that's left over. I canceled those out. 7 times 7 is 49, and we should verify that, which this is the nice thing about algebra, is if you verify your solutions, you'll never get a question wrong. 49 over 7 equals 7. I'm good to go. Okay, those are the examples. I hope you find this helpful. Please make sure to put a comment if you don't understand something that I did here. This type of question is often the most confusing for people. It's hard to get used to seeing that format, but once you get used to it, it's actually going to be your friend in the long run. It'll make your life way easier if you can learn to cancel things out. That if you have the same thing on the top and the bottom, canceling fractions out will make your life way easier in the future.